So moving on with Unit 1, today we're going to talk about something called a piecewise function. So we've talked about our different parent functions like our squaring, cubic, square root, all 6 of those parent functions. Now we're going to talk about a different type of function that's called a piecewise, which is really just a combination of taking different parent functions that you know and putting them into one graph. So after today you should be able to graph and evaluate piecewise functions. So what exactly is a piecewise function? If you look over on the right side, I've got this like shattered glass. And if you think about each little line, so like there's a segment of a break, here's another segment of a break, here's another segment. If you could actually write an equation that would represent each one of these little lines, you'd basically be making a piecewise function. So a piecewise function is a bunch of little pieces of other graphs put together as one. So for definition, what is a piecewise function? It's a function defined by different rules over different subsets of its domain. So those two terms there in red, different rules over different subsets of its domain. And if you look below, a piecewise function looks like this big guy right here. So f of x equals, and you've got these 3 lines after that bracket. So again, we've got rules and we've got subsets. Okay? A rule would be like these pieces here on the left side closest to the bracket. This has 3 rules that define the function. Negative x, 2x plus 3, and negative x squared are 3 different rules. In other words, you've got 3 different equations that make up this one single function. Now the second part is over different subsets. So this rule, negative x, is only used if we're talking about x values that are less than negative 3. So this is the subset for this rule. 2x plus 3, that equation, is only used if we're talking about x values that are between negative 3 and 2. So this is a subset for this rule. And then finally, if we're talking about x is greater than 2, then we're talking about the negative x squared rule. So over here on the right it says, let's evaluate this function over these 4 values. So like it says, find which subset the value falls, then substitute in the corresponding equation. So if I want to evaluate f of negative 5, well, negative 5 would fit into this subset because negative 5 is less than negative 3, which means I would use this rule. So it would be negative 5. Because it's negative x, I'm putting negative 5 in for x, so negative 5. So if I evaluate f of negative 5, I would just get 5. Now let's evaluate f of negative 1. Well, negative 1 would fit into this middle subset because negative 1 is between negative 3 and 2. So to evaluate negative 1, I would use this rule. So 2 times x, so 2 times negative 1 plus 3. So that would be negative 2 plus 3, and I get 1. If I wanted to evaluate f of 0, that would actually go into this same subset because 0 is in between negative 3 and 2. So I would use that same rule. So 2 times 0 is 0, plus 3 is just 3. If I want to evaluate f of 3, well, 3 would fit into this subset because 3 is greater than 2, so I would use this rule. So negative 3 squared, I'm putting 3 in for the x. Notice the negative is not in the parentheses because it's not in parentheses over here. So 3 squared would be 9, so my answer would be negative 9. There I'm just squaring the 3, not the negative. The negative's out front. So evaluating these functions is pretty simple. You're just going to look at what x value you're trying to evaluate at and make sure you place it in the correct subset so you use the correct rule for the piecewise function. Alright, my shattered glass example might make a little bit more sense once we kind of look at these guys graphically. So let's try to graph one. So here is a piecewise function with 2 rules to it. So I want to graph f of x equals x plus 2 if x is less than or equal to 0, and 1/2 x squared if x is greater than 0. So I have 2 rules, 2 different subsets. So here's what we're gonna do. We are going to write each rule separately down here. And what we're going to do is we're going to make an XY table for each rule. So we're going to find at least 3 points. That's the minimum you have to do. 3 points for each rule, and then we'll graph it. Now, one thing to kind of recognize is this piece here is x plus 2. You should be able to recognize that that will be a linear equation, so a straight line. This guy is a quadratic, right? So that's going to have kind of that parabola curve. So part of our graph should be a straight linear line. Another part of our graph should be, a part of a parabola. So let's work with x plus 2 first. So our subset here is any x's that are less than or equal to 0. So 0 is where I'm going to start my x's. Always start your x's with the number that's on your subset. So x is less than or equal to 0, I'm going to start with 0. Now it says x has to be less than that. So I need 2 more numbers less than 0, so I'm going to go -1 and -2. So these x's came from the subset. It starts at 0, and it says any x is less than 0. So I just pick the next 2 numbers less than 0. Now all I'm going to do is take these numbers and plug them into x. So 0 plus 2 would be 2, -1 plus 2 would be 1, -2 plus 2 would be 0. Now notice it actually equals 0 in the subset. So 0 is included in the subset. So just for reference, I'm going to put a closed dot by this 0 so I can remember that it's included in this subset. Okay, on to the second rule. Second rule is 1/2 x squared. Where do I start my x's? Again, I'm going to start it with whatever number the subset starts with. Now this says it's 0 and any x greater than 0. So I'm just going to pick 2. 1, 2. 1 and 2 are the next 2 numbers, whole numbers greater than 0. I could pick any number I want, but I got to try to maintain my graph inside my, my window for my graph here. So now I just plug in 0 squared would be 0 times 1/2 is 0. 1 squared is 1. 1 times 1/2 is 1/2. 2 squared is 4. 1/2 of 4 would be 2. So all I did to get these y's were plug my x's in my rule here. Now, look at this subset. We started with 0 because that's where my subset started, but this is not equal to 0. So 0 is actually not included in this rule, so I'm going to put a little open circle by that point. Remember, or equal to means it's included. If there's no or equal to, it is not included, so that would be an open circle. So now I'm just going to graph these points. So for my first rule, it's 0, 2. So 0, 2, and that's a closed circle. And then every other point in my table would be a closed circle. -1, 1, -2, 0, and then this would continue on. So I have these 3 points to start the line, and then I can just continue it on. Now my next one, 0, 0, that's going to be at an open circle because again, 0 is not included in that subset, so it gets an open circle. The rest of the remaining points in the table would get closed circles. So 1 and 1/2, so 1 and 1/2, and then 2, 2, right there. So here's kind of that parabola part, right? And it's going to go back up like that. Whoops, 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 whoops. Starts here and has that curve like that. There we go. So disregard that previous one. So it starts at 0, 0 and then has that curve going up. Remember, it's quadratic, so you've got that parabola piece. Let's try one more. So here's another one. This one has 3 rules. This was actually the one we evaluated earlier. So I'm going to write my 3 rules and I'm going to make an XY table below it. So write your 3 rules and we're going to grab some points for them. Now, again, where do I start my x's? I start with whatever x my subset starts with. Notice -3 is not included in this set, so I'm going to mark that with a little open circle so when I graph it I know if it's open or closed. And this says x less than -3, so less than -3 would be -4, -5, okay? And how do I get my y's? I just plug it in. So negative, so again this would be like -3 because there's a negative on the rule and I'm putting a negative in, so that would actually be +3. So negative negative 4 would be 4. Negative negative 5 would be 5. Okay, moving on. The next one is for negative 3. Now this is interesting. This is a bounded interval, right? The one before here that was x less than negative 3, that's unbounded. So it's like every number less than negative 3. The second subset starts at negative 3 and ends at 2. So I'm going to start my table at negative 3 and I'm going to end it at 2. So whenever you have this bounded interval where you start at a number and end at a number, you have the beginning and the end of your table, and then you just have to pick any random number in the middle. So like, what's in the middle of negative 3 and 2? Well, something easy would be 0. So there's my 3 points. Now notice negative 3 is included and 2 is included in the subset, so both of these would get closed circles. So let's plug them in. 2 times negative 3 is negative 6. Negative 6 plus 3 is negative 3. 0 times 2 is 0, plus 3 is 3. 2 times 2 is 4, plus 3 would be 7. Okay. One more here. This last rule, the subset starts at 2. It's not including 2. Remember, 2 is in this subset, so I would put an open circle on that one. And I need any x greater than 2, so I'll just go 3 and 4. So here's 2 squared. Now this, when you substitute, would look like this, negative, and then you're squaring the 2. So it's 2 squared is 4 with a negative in front would be this. Again, here would be negative, and you're squaring 3, so that's 9 with a negative in front. And finally, 4 squared is 16, negative 16. All right, so now I'm just going to graph. So over here on my first rule, again, negative 3, 3. Since negative 3 is not included, it's an open circle. So negative 3, 3 would be right here open. And this is just a linear equation, so it should look like a straight line. Negative 4, 4 would be here. So that negative 3, 3 is open, but every other point after that would be closed. And there's that one. And then again, that's just a nice line that goes this way. Now let's jump over to the next rule. I'm starting with a closed circle at negative 3, 3. Negative 3, negative 3, which would be here. 0, 3 would be here, and then 2, 7 would be right there. And again, this is a linear equation, so it's just going to be a nice straight line. Now this last one is quadratic, so I should have a little bit of a curve to it because it's part of a parabola. Starting with an open circle, 2, negative 4, so that's open, and then 3, 9, 3, negative 9 would be down here. Remember that first one's open, but the remaining ones would all be closed. Then 4, negative 16. So I'm going to draw my point here, and then I'm going to draw that little curve. Remember that is a curve because it's a parabola. All right, so we've graphed piecewise functions. We've seen how to evaluate them. So hopefully now you can evaluate and graph piecewise. Oh, we got a little special guest here. Oh, look who that
But
is.
can you
Oh, man.
evaluate and graph? Do you know what it means to evaluate?
I hope so.
I think they do.
I think it looks like this now.
Oh, yay!
Oh, geez.
They did it.
All
Good
right.
job.
Bye.
Bye.